My name is Nicholas Wenner, and I am presenting FiberShed's Fiber Visions project. For this project, we created graphics to visualize regenerative annual cycles for three fibers in our region, dogbane, wool, and cotton, and grounded those visions with textiles made locally from those fibers. In this session, we are focusing on cotton. I will present the graphics, which will also be shared online, and the textile samples, and we will hear from a local cotton farmer about what's happening on the ground at this point in the cycle in October, November 2020. These are the baseline graphics for the cotton series, and you can see that time flows from left to right, and that we've broken it into two seasons, the wet season and the dry season. And we would often hear from farmers that the year starts in November when the rains come. And it really makes sense for our landscape. And this is based in Southern California. It makes sense to have these two seasons. There's a wet season from November to March roughly, and a dry season from April to October. And the graphics from left to right show practices like cover cropping, no-till planting, harvesting, alley cropping. And these graphics present an ambitious but achievable vision for California cotton that integrates proven individual practices into a cohesive and regenerative whole. And FiberShed is supporting ongoing field trials to prove out this vision at the commercial scale and working with farmers including Nathaniel Siemens from Fat Uncle Farms, who we will hear from later on. So focusing in on the wet season, from left to right, as cotton that was harvested at the end of the previous season is ginned, cover crops are planted without tilling and allowed to grow and feed the soil. At the end of the season, the cover crop is terminated and cotton is planted directly into the residue. And we will focus in on specific aspects of the scene, and these graphics will be shared online, and there we will provide more resources and more details about each of these. And here in this presentation, we'll give an overview. So the first one, compost application. Compost provides readily available nutrients and inoculates the soil with beneficial microbes. Multi-species cover cropping. Diverse and healthy plant roots support diverse and healthy soil communities. Together, they provide pathways for water, carbon, and other nutrients to enter the soil, which acts like a sponge and keeps them cycling where they are needed. No-till planting. Seeds are planted without tilling to maintain the soil structure, which is critical for water infiltration, soil function, and preservation of organic carbon. And we're presenting the agroecological cycles in these graphics. We're also showing the vision for manufacturing. And the first step for manufacturing with cotton is ginning. And there, workers gin cotton after harvesting to remove the seeds and the short fibers. And we have industrial scale ginning in our state. The seeds from the ginned cotton are used for cattle feed. And in the background, we also have a spinning facility where workers card, draft, and spin ginned cotton into yarn. And this is one of the aspects of the vision that we don't have yet. We have ginning, but we currently need to send our cotton elsewhere to be spun. And here's a graphic that sums up everything that I just shared. And again, these will be available online. And now zooming into the dry season. So moving from left to right, cotton grows as the field is irrigated and weeds are managed. Cotton bolls develop after irrigation is halted around August. And prior to harvesting, the plants are made to drop their leaves. And after harvesting, the sheep graze the stubble and prepare the soil for the coming rains so that the cycle can start again. And again, we'll focus in on a few specific aspects. So the first one, maintaining cover. Dead cover crop materials from the last season create a layer on top of the soil, which keeps the soil covered, maintains ideal temperatures, reduces evaporation, and reduces the buildup of salts in the soil that would occur from that evaporation. Carbon sequestration. Plants transfer carbon from the atmosphere and energy-storing sugars to the life in the soil. In turn, microorganisms support the plants and store carbon as they build soil. When carefully managed, these processes can address climate change. Alley cropping. So integrating row crops and tree crops can diversify income, improve production, and increase carbon storage. And FiberShed is helping work on some trials right now to plant some trees like mulberry and olive for alley cropping trials with cotton. On the manufacturing side, we show a weaving or knitting facility where workers weave or knit yarn into fabric, and the mills are powered with renewable energy. We also show a dyeing and finishing house in the background where loose fibers, yarns, fabrics, and garments are dyed using natural materials, and the wastewater is treated and applied to the fields. And this is another area where we have a lot of dyeing in California, but not a lot of large-scale natural dyeing. So this is another part of the vision we'd like to see come into being. And riparian restoration can be a part of this vision, where a lot of cotton farms in California are in or next to riparian areas or historically riparian areas. And restoring river areas supports biodiversity, sequesters carbon, and protects water used for irrigation from pollution and evaporation. And any facilities like a natural dyeing facility could send wastewater through a managed wetland to help in the processing of that wastewater before releasing further. And here's a graphic that sums up everything I've shared, and these will be available online. So we've presented a vision for regenerative cotton in California that takes proven practices like cover cropping and no-till cultivation, and newer practices like alley cropping, and presents them in a cohesive whole that could provide regenerative fibers. And we've also shown a vision for manufacturing that could process those fibers and help create textiles at the scale we need to have a truly place-based cotton system in our region. And here we're showing a textile related to this project. This is the California Cloth Foundry's rib knit fabric. And this was made with Sustainable Cotton Project certified cleaner cotton. And it doesn't necessarily represent all of the practices we've shown in the vision so far, but it represents a transition in that direction. So the cotton is Pima cotton grown in the San Joaquin Valley, and it's certified cleaner cotton, meaning it used non-GMO seeds and was grown without using the most toxic pesticides and herbicides. The cotton was ginned in the San Joaquin Valley in one of the 18 gins we have in the state, which produce more than 400 million pounds of ginned cotton each year. And you can see the unginned cotton at the bottom after harvesting, and the ginned cotton at top where the seeds and other plant matter have been removed. And this is the California Cloth Foundry rib knit fabric. The yarn for this fabric was spun in North Carolina because, again, we don't have the cotton spinning capabilities yet in our region. But it was knit and finished in California. And so this represents a transition in the direction of the visions we've shown, where it was manufactured largely in California, grown without GMO seeds, and without using the most harmful pesticides and herbicides. And now we're going to hear from Nathaniel Siemens from Fat Uncle Farms about ongoing trials to incorporate the rest of the vision.
2 years ago we got out there and it was just a wasteland. The salinity levels were off the charts and nothing was growing. It's just like, I planted some grain in there just as a trial. I had a whole bunch of different varieties of grain and nothing came up. Like big fat zero. It was amazingly uh, uh, impacted ground. We put the cover crop in, and we got a little bit of stuff coming up, and we go, okay, well, that's good. Some of these species are going to work in this environment. We got a little bit of biomass out there, and then we got some sheep out. We got some mulching out there, and this was stuff that I presented, I think, last year in the symposium, was kind of the stuff what we were doing year one. And then got a little bit of like cow manure out there, so also high salt. So the salinity is still high. We're still worried about everything growing, but this last year when we put the cover crop in again, second year cover crop, now everything grew. Every single species we put out there grew, which is just like shocking to me. Like, what? How did this happen? The no-till also, I mean, in those, we've been no-tilling for 2 years also, and that feels pretty good too. The cotton had a much higher germination rate in year 2 than year 1 on the ground that was no-tilled. Obviously, the alley crops, which are kind of in the background in there, is where we're putting a lot of our effort, and where there's a lot of design components that I'm excited about. That's kind of an interesting puzzle and challenge to put together. There's almost no real risks about it, other than that it's complicated. But I think at the end of the day, like, the complication part is really the exciting part to me, and I think that's like monocropping is kind of almost an accident that we found ourselves. That my grandfather, my grandfather, like, decides to put in to tear out all his cotton and put in trees. And why did he do that? Well, there's a lot of socioeconomic reasons that farmers make decisions, but at the end of the day, like, we know that monocropping doesn't work. That it's driven us into so many dead end roads. And I think that the diversification aspect that alley cropping avails us is, just speaks to a lot of advantages, and also an aesthetic that's a much more human aesthetic. So, and I think at the end of the day, that complication and that layering and the aesthetic is what's exciting. I think that's what, like, is going to draw people in. It's what draws me in. Pictures worth 1,000 words, but once we're allowed to be a little bit less socially distant from each other, come out and visit the farm. That's worth even more words than a picture. So I hope that your graphic is an invitation for people to come out to our site and get dirty and play in the mud.
And I'll leave it at that. So thank you for your time, and thank you, Nathaniel Siemens, Kelsey Brewer, Jessica Chiartas, Lydia Wendt, Amanda Cohen, and Jess Daniels.